Okay, so lesson 35, the last lesson that we did, we learned about circles and ellipses. And I didn't really tell you that these are all known as conic sections, but let's look at why. So if you had two cones with the points together, like these blue ones in the picture, and then you slice through with a sheet of paper, what would the cones look like on that slice? And it depends on how you cut through the cones. So if you go straight across, it would be a perfect circle. So that's our first one. A circle is one conic section because you can cut the cones and you get a section of it. So that's the conic sections. If you cut through kind of at an angle in an upwards direction, or downwards, I guess, it doesn't matter, you're going to get that oval shape or the ellipse that we studied last time. If you cut through all the way off the side at the top, or maybe you do the bottom cone, you would get this U shape, and we call that a parabola. So that's the first graph that we'll look at today, is a parabola. If you were to cut through both the top and the bottom cones, you would get two U shapes, and so that's called a hyperbola. So we're going to look at parabolas and we're going to look at hyperbolas. You're going to use these a lot more in Algebra 2, so this is just kind of an introduction, but just expect more of it in your next algebra class to really know how to graph these well. We're going to do it kind of what I think is like the easy way, just to do the XY chart like we did last time. But there are ways, like I showed you with the circle, how you have the standard equation, and if you pull out the numbers in the right way, you can get the center without having to plot points. The same thing can be applied to parabolas and hyperbolas, but it's a little bit more complicated, so we're not going to do that at all today. We're just going to plot points with an XY chart. And in fact, your book and your homework and stuff will already give you the X coordinates, so you're just going to plug them in, find the Y, plot the points, but you have to know what the graph should look like. So you have to know whether you're going to be making two U's or one U or a circle or an ellipse. So here we go. A parabola can look like any of these. It can be sideways. We won't be doing the sideways ones this time, but that's if Y is squared. The ones we will be doing is if X is squared. So if X is squared, with any kind of number or anything with the Y's or the X side, then you're going to get either a right side up U or an upside down U, like a rainbow. And these can be, like in this picture, I would consider these kind of wide. You might even get, a really skinny one like that. You can get like super skinny ones that come, really close. You can get them to be moved over. So it could be, an upside down skinny parabola that is over here, or you could get a right side up one that's over here. So whether they're skinny or fat, upside down, right side up, moved around so that they're not on the origin, all of those would be parabolas. A parabola comes from the variable being squared. And like I said, in our book, we're only going to be working with X squared. Okay, so let's try to graph a few that are on your homework sheet. Okay, so we have just the basic one, that's Y equals X squared. If X is 0, I'm going to plug in 0 for X right here. So I'm going to get 0 squared, which means Y would be 0. If I put in a 1, I would say Y is equal to 1 squared. 1 squared is 1, so Y is equal to 1. If I put in a -1, I square the whole -1, so -1 times -1 is still +1. So Y is still 1. If I put in a 2, 2 squared is equal to 4. And then if I put in a -2, -2 times -2 is still positive, and it's a +4. So now we're going to graph these points. The first one is at the origin. And then we have 1, 1. And then we have X is -1, but Y is still a +1. And then we have 2 up to 4. And then we have -2 is also a +4. So once you get these points, do not draw a V, but make sure it looks like a U. So you want it a little bit curved at the bottom, not a straight point. And so you can start a little bit above, draw through those points in a curved shape as best you can. To note, there will always be a vertex is what this is called. So the vertex is just the kind of where the U is at the very bottom. And parabolas will always be symmetrical. So you shouldn't get points on this side and then maybe points out here. Wherever that vertex is where you should be able to fold it in half and it would look the same on both sides. Sometimes the vertex might be over here, so it's not like it's always a 1 with a -1. It could be a 4 with a 6 for the matching sides. But they will be matching when you graph them. So look for that when you're graphing parabolas. Okay, any major questions right now? All right, let's go to the next one. So what does it look like if we have a 1/2 in front of our x squared? So I'm going to plug in 0 for x first. So I have a 1/2 out in front, I have a 0 squared. Well, 0 squared is 0, and 0 times 1/2 is 0. So this one is still at 0, 0. Let's plug in a 2. So y equals 1/2, 2 squared is what? So 2 squared is 4. 4 times 1/2 is 2. Now I'm going to plug in a -2. Well, our -2 squared is also a +4. 4 times 1/2 is 2. Now I'm going to plug in 4. 4 squared is 16. 16 times 1/2 is 8. And then our last one, 1/2 times -4 squared. So -4 squared is still a +16. 16 times 1/2 is 8. So I know that 2 is going to be 2, and 4 is going to be 8. 2 is going to be 2, and -4 is going to be 8. Whoops, I missed one point going through. Okay, draw yours a little bit better, but that's how that compares. And let's just look at what it looks like versus the one up above. So if we were to keep going on this one, 3 would be 9. This one is skinnier, right? This one that was y equals x squared is skinnier compared to this one down here that's y equals 1/2 x squared. So that 1/2 makes it a little bit fatter. So imagine if we had y equals 4x squared, that one will be really skinny versus even this one. So just to note, you can kind of start to look at the patterns. It's not required for this class, but it's something to kind of note as you look at them. How did that change in the equation make the graph look different? Okay, so our last one, I don't know what happened to my XY chart, but we're going to do this one over here. If you don't, I don't know if your notes have an XY chart and I didn't copy it. But anyway, here we go. I do not know what numbers to pick because I didn't look at this earlier, but we'll start with this and just see where we get. We may need to do -2 also. Okay, So let's say we plug in -1. So our equation is -2x squared. So -2, we're going to plug in a -1 and square it, and then we're going to add 1. So that's what our y is going to be. So -1 squared is +1. +1 times -2 gives me a -2. -2 plus 1 is a -1. So when we plugged in -1, overall we get a -1. Now let's plug in 0. So 0 squared is 0. 0 times -2 is still 0. 0 plus 1, so we just have a 1. Now we're going to plug in a +1. And if you think about what we've been doing, every time we plug in a negative and a positive, they come out the same. So let's double check and make sure that's the same here. 1 squared is 1. 1 times -2 is -2. Plus this 1 comes out to be -1. Now we'll plug in a 2. Oops, I forgot the square. Okay, so 2 squared is 4. 4 times -2 is -8. Plus 1 is -7. And then our last one, we're going to plug in a -2. And again, knowing our pattern and knowing what we've been doing, this should be the same one as this one. So -2 squared is a +4. 4 times -2 is a -8. Plus 1 is -7. So I'm going to start by plotting 0, 1. So no x, but a +1 for y. If x is -1, I get -1 for y. If x is +1, I get -1 for y. If x is +2, I get -7. And if x is -2, I get -7. So this is now our vertex, and we can see that the u must be upside down. So remember to curve it just a little bit. I missed that point, sorry. So this one is one of those upside down ones. Usually you'll see if there's a negative number in front of the x squared, you'll get an upside down one. All right, feel free to ask questions. That's it on parabolas. Now we're going to do a couple hyperbolas, and then we'll be done. So a hyperbola is like two u's in opposite direction from each other. And they can be in all different directions. So sometimes we'll see them up and down. Sometimes we'll see them sideways. And sometimes we'll actually see them kind of at a diagonal. Okay, so what you're going to be looking for in a hyperbola is two u's opposite of each other. So when I draw this, this line never connects to this line, which is different than what we've seen in all of our other graphs. Okay, so let's try the graph of xy equals 4. Oh, did I not say? So the key to kind of knowing what a hyperbola looks like is when the x and the y are multiplied together. Okay, so xy equals 4. If x is 1, what is y if I have an answer of 4? So I'm going to divide by 1, and y would be 4. So really, on this simple one, we're just looking at whatever I have for x needs to be multiplied by y to get 4. So y has to be 4 if x is just 1. So if x is 2, I have 2y equals 4. I divide both sides by 2, and I get that y is equal to 2. If x is 4, then I have 4y equals 4. I divide by 4, so y has to be 1. Now let's do the negative. What happens if I plug in a -1 times y equals 4? I divide by a negative, and so I get y equals -4. I would have to have two negatives multiplied together, x and y, to get a positive. So then I think we can do these without maybe writing it out. If x is -2, if x was +2, it would be a +2, but because it's negative, it's going to be a -2. And the last one, if x is -4, I have to multiply by a -1 in order to get a +4. So now I'm going to plot these points. X is 1, y is 4. X is 2, y is 2. X is 4, y is 1. And then on the negatives, we have x is -1, y is -4. X is -2, y is -2. X is -4, y is just -1. So do you see, this might be hard if you didn't know what you were looking for, but since we know we're looking for a hyperbola, we know we want to connect these in a curved shape, and we want two of them opposite each other. So we're not connecting across at all, but we're going to be connecting these three in a U shape. This one's a really wide one. Hyperbolas tend to be more wide than the parabolas. And then this one will be connected in a curved shape. All right, last example, we're going to look at the difference between xy equals 4 and xy equals -4. So let's do this last one. If I have xy equals -4 and I plug in 1 for x, what does y have to be? Well, I divide by 1 and I get y is -4, which made sense because now we need a negative, so we're going to have one positive and one negative for our x and our y. So if we plug in a 2, we divide by 2, y is equal to -2. And I'll move over here. If I put in a 4, 4y equals -4, then I'm going to divide by 4, and I'll get y equals -1. And then hopefully you're seeing the pattern. If I put a -1 in, now I'm dividing by a negative, so y has to be +4. If I put in a -2, I'm going to get a +2. If I put in a -4, I'll get a +1. Scroll down a little bit and see what this graph looks like. So if x is 1, y is -4. If x is 2, y is -2. If x is 4, y is -1. And the negative x, -1 will be a +4, -2 will be a +2, -4 will be a +1. And just like I'm connecting these in the same quadrants, not across, I'm going to connect these also in their quadrants right here. Okay? Oh, I still don't have it. Anyway, for your homework, I'm editing just a little bit, so you only have to do 35A and 35B. You do not have to do C and D. And I'm doing that because I kind of forgot that you guys have a final next week, and I wanted to give you a couple days to maybe look over the review and do that for your final, to study for your final. So now, do you have any questions about things?
Yeah, on number 2 on 35A, it says xy equals 6. How would it be the same as the other one?
Yeah, I'm looking to see. Okay, I don't have the worksheet in front of me, but yeah, it would just be like those last two on our worksheet, where you're going to plug in some numbers for x and see what y will be when they have to multiply together to be 6. So if you plug in 1 for x, 1 times what equals 6? 1 times 6 equals 6. So 1 for x would be a 6 for y.
Okay.
So it should look very similar to those last two on our notes page.
Yeah. Okay.
All right. I didn't say that your final was any extra credit, did I? I mean, your review. I don't think so. But we will do your final where it'll just be every two questions together. So like question 1 and question 2 will be very similar. As long as you get one of them right, you get full credit. If you get the second one right, you'll get an extra point. So I still haven't made your final, so I don't know exactly how long it's going to be. But now you have a little bit more than an hour if you want. I will give it to you where you need to take it as soon as you open it, so be ready to take it, have some extra paper with you to do some work on, because you'll just be putting in the answers. But I do want you to like send me pictures of your work once you're done with your final, so that if I can give you any partial credit on something, I can.
Okay.
Okay.
Yes, ma'am. Really easy.
Well, again, you'll have 2 problems for each type, so
Okay.
hopefully one of them. And then you have time, because I'm not now pinning you down to an hour. So if you work on it for 2 hours and do all of the problems, then hopefully you've gotten at least one of the 2 right, and then the extra will be extra credit.